looking at the size of the atom earlier on, and we're looking at this simulation called Scale of the Universe 2. Presumably they had a previous one, and this is an updated version. Let's zoom out for a moment. There's a quail egg. There's a shrew, a chicken egg, Russell's teapot. This is the fabled teapot that could be orbiting our planet. But anyway, that's a sort of philosophical discussion. We won't go into that right now. It's to do with religion, actually. Anyway, now we're looking at this is what an ant is. Over here we've got a sunflower seed. If we zoom in even further, this has got a human egg. This circle represents the smallest object visible to the naked eye. So anything else we won't be able to see beyond that point. Width of a silk fiber. We've got the largest virus there. We've got a transistor gate. These things are inside microchips. We're starting to starting to see molecular structure. Here we go. So now we can see our first atom. There's an atom there, and here's a cesium atom. We're actually able to see the electron shells there. If we go a bit further, that's a water molecule. So a water molecule is actually smaller than a cesium atom. There's a carbon atom, and here's a hydrogen atom. So now we get a rough idea. That is still actually not to scale. This nucleus is still not to scale. But so if we go a bit further, we'll actually start to see the size of hopefully you'll see the size of a nucleus. There we go. That's the size of a uranium nucleus, which is quite large. There's a helium nucleus or a proton. So that's how small a helium nucleus is there, and a proton. If we zoom out, we can see just how tiny the nucleus is compared with an atom. So this is the size of a helium atom right here, and that bit isn't accurate. So, but when you zoom in, you'll see the size of a helium nucleus in reality, and you can see it's extremely tiny. So the analogy they often give is a fly in a cathedral. Imagine the atom was the size of a cathedral. The nucleus would be the size of a fly. So most of matter is actually empty space. If you get rid of all the empty space in all the atoms in a mountain, then the entire mountain would fit onto a teaspoon. And it will still weigh the same because it's still the same amount of matter. You've just got rid of the empty space. So, and there are things in the universe that are made in that way, and they're called neutron stars, and they're extremely dense. Anyway, let's go a bit further, and you could start to see some other things. We're not going to look at too much, but just briefly, quarks are essentially, they make up the protons and neutrons. And you go even further, you got these other types of quarks, which are different sizes. You got something called a neutrino, which are almost entirely undetectable. Suddenly we don't get anything for ages, and we keep going down. Doesn't seem to be anything there, but eventually we will see something. If we go, here we are. We have something called the Planck Length. And this length represents the smallest length that can possibly exist. And we have these things called quantum foam and string. And this is to do with when they talk about string theory and so on. And also they refer to something called M theory. And that's basically apparently what all of reality is made out of. But it's all a theory, of course. I don't know if we'll ever actually get evidence to prove that. So there's a brief introduction to atoms. We're going to look, a beginning of the introduction. We're going to do even more on that in a moment. So let's just stop that video there. That'll be our part 2.